Hello, everyone. Thank you for joining the Association of Pacific Rim Universities APRU Multi-Hazards Virtual Summer School Part 3. It is my great pleasure to welcome you again to this virtual summer school. This is organized by the APRU Multi-Hazards Program and the International Research Institute of Disaster Science, APRU-IRIDeS, Tohoku University in Japan. I'm Takako Izumi, Associate Professor of Tohoku University and Program Director of the APRU Multi-Hazard Program. So I will do the moderator for today's session. Most of you may already know APRU is a network that consists of 55 universities in the Pacific Rim from 18 economies, and its international secretariat is based in Hong Kong. It brings researchers, academic leaders, and policymakers together to collaborate on effective solutions to various challenges. It focuses on leveraging the collective education and research capacities into the international public policy in various programs, including natural hazards, women in leadership, population aging, global health, and others. And you can receive more information on the APRU events and the program on its website. And I will talk more about the multi-hazards program later in my short presentation. The topic of today's webinar is latest research in disaster science. And we have three speakers. Firstly, Professor John Landro from UC Davis, and Professor Benito Pacheco from University of the Philippines, Diliman, and Dr. Rianti Dujalante from United Nations University, Institute for the Advanced Study of Sustainability in Tokyo. So while you're listening to the presentations, I'd like to encourage you to send us questions using the Q&A function. After each presentation, I will take questions from the audience and ask the speaker to answer the questions. Also, we would like to ask you to share the webinar information and tag at APRU1997 and hashtag APRU+ on Facebook and Twitter. Okay, so now I'd like to introduce APRU Multi-Hazard Program very briefly. So APRU Multi-Hazard Program established in APRU in April 2013. And IRIDeS, and that secretariat is in IRIDeS, Tohoku University. Then the core group, and we formed the core group, and that consists of 12 members from UC Davis and University of Hawaii and University of Chile, and Chulalongkorn University, National Taiwan University, and University of Philippines, Tsinghua University, and Tohoku University. So we have two main objectives. It's to harness the collective capacities of APRU universities for cutting-edge research on DRR. Then second is contribute to the international and regional discussions to make an influence in the DRR policy-making process. So there are a couple of focus areas in the multi-hazard program. So firstly, in the field of research, and we really promote the collaborative researches through a lot of publications. And I will introduce a couple of publications we already published. And the first one is the book, it's called Science and Technology in DRR in Asia. So that paper is based on the abstracts presented at the APRU Multi-Hazard Symposium. So we collected all these papers and published and compiled as a book. Then we recently, well, it's 1 or 2 years now, but we issued a new international journal. It's called Progress in Disaster Science. It's published by Elsevier. Then we published also 30 innovations for disaster risk reduction. And the second volume is that 30 innovations linking DRR with SDGs. So you can download these publications from the APRU website and also the APRU Multi-Hazard website as well. And in the field of education, we mainly organized two events. First one is that the Multi-Hazard Summer School. Unfortunately, this year is the virtual, but usually we invite the participants to the Tohoku University in Japan. Then that will be the 4-day course, then which includes the 1-day field trip. Then second one is that a multi-hazard annual research symposium. And this event is hosted by one of the APRU member universities. And unfortunately, this year was not organized due to this COVID-19 pandemic. But next year, hopefully, University of Indonesia will host this event. And I also would like to highlight the journal, as I just mentioned, we recently launched. The title of the journal is The Progress in Disaster Science, and that focuses on the holistic perspective on disaster research. And it also highlights the overviews, case studies, and challenges regarding the implementation of the Sendai framework. And also it collects the case studies and papers among multi-stakeholders and implementation-oriented research. And in another field includes the new collaboration with practitioners. And we are working very closely with international organizations like IFRC. It's the International Federation of Red Cross and Red Crescent. So we exchange speakers and also try to conduct some joint research as well. Then we try to contribute to international discussions through various events, such as a global platform on disaster risk reduction and Asian Ministerial Conference on disaster risk reduction. Then in Tohoku University, every 2 years, we organize the World Bonsai Forum. So we also organize some sessions at World Bonsai Forum as well. Then led by UC Davis, and we also organize a Global Navigation Satellite System Early Warning System Workshop and Data Science Workshop as well. Then as a new initiative, and we have the project together with UCLA, and it's called Architecture and Urban Design for Disaster Risk Reduction and Resilience. So this project has been just launched, and we will have a series of activities in the next, probably next 3 years as well. Then another unique program we have is that it's called the Campus Safety Program. So it aims to strengthen the disaster preparedness capacity on campus, and including different types of hazards, not only natural, but also the biological and chemical hazards. Then main activities include to take survey among the APRU member universities on the level of the disaster preparedness capacity. Then we organize a campus safety workshop every 2 years to share the experiences and also to discuss the common concerns. Then the current ongoing program and activity is that to collect case studies of disaster response and recovery, including the experience of the COVID-19 pandemic. So I hope to share these case studies towards later this year or next year as well. Then why this campus safety is important is that even the UN ICDR and currently UNDRR, their Asian Pacific Technology Conference, they highlighted the importance of university to develop a disaster management plan, which increased their governance on campus. So this is my last slide. The Multi-Hazards Program continues to strengthen the research capacity and to provide a learning opportunity for students and faculty members. Then we try to work with other stakeholders such as practitioners and governments and private sector. Then lastly, to share scientific evidence for policymaking. So I hope you will join us, and we invite you to the several activities like summer school and also annual symposium. Okay, so thank you very much for your attention. Okay, so now I would like to invite the first speaker. Wait. Okay, sorry, we are just, okay, sorry, and we will change the order of the speakers. So now I would like to introduce Professor Benito Pacheco at University of the Philippines, Diliman. And he is professor at the Institute of Civil Engineering, University of the Philippines, Diliman in Quezon City, Philippines. And he is also academician, member of National Academy of Science and Technology in the Philippines. Among his recent engagements are national projects to review and replace the Philippine legislation that regulates building design and construction throughout the country, and to update a national framework of prioritization of multi-hazards retrofit of school buildings. And he's also a core member of the APRU Multi-Hazard Program, and he is actively participating in the multi-hazard program as well. So thank you so much, Professor Pacheco, for your participation today. And we are very lucky to have you today. So our floor is yours.
Thank you for the kind introduction. Our membership in this Association of Pacific Rim Universities covers 18 economies at different levels of development. The Pacific Rim itself is known for a multitude of natural hazards, which pose very real challenges to our pursuit of sustainability. And such are the multiple hazards in my country, perhaps similar to yours. I'm glad to be back in our Multi-Hazards Summer School. My topic today about regulating buildings is just in the middle of the social science and policy of DRR and the data science and physical science of forecasting great earthquakes. So, let me share with you our recent legal and technical research on the matter of building regulation for resilience. One output has been the proposed act or law to replace the current law, which is 43 years old, an act regulating the planning, design, construction, occupancy, and maintenance of buildings. Our objectives today are two: a review of the history of nationwide regulation for buildings, and an explanation of key features of the proposed new national act that would also reset the stage for innovation. We may start with a side story of Newton, who also experienced working from home during an epidemic. We continue using Newton's laws in our engineering of buildings. If we act according to Newton's laws of physical sciences, all our buildings will be resilient, right? Well, it may still be the opposite. There's much more that we need from the social sciences. The shortened title of my presentation today, therefore, is shelter. Let's say this terminology is from the point of view of the end user of building, rather than the point of view of the architect or engineer. Let's say this is a more social approach. Shelter is possibly a solitary house, like the residential building of Isaac Newton. Shelter is possibly a hub or node or server for communication. Indeed, shelter is in the middle of the many concerns that we are addressing these days in relation to sustainable development. We are reminded, especially in the time of COVID-19, that shelter is the most basic infrastructure. How about buildings? Well, the current old law, as well as the proposed new act, both affirm that every building is a shelter and more. Occupancies in buildings can be as varied as the following types. So, people of all walks of life are concerned about buildings. We're all concerned. Shelters such as these in the Greater Metro Manila area are exposed and vulnerable to earthquake and other hazards. And so are we, the occupants. From this year 2020, we can look back to an earthquake of 1968, 52 years ago, that inspired the adoption of our first national law regulating buildings. And then a tsunami about 4 years later that prompted a quick replacement by another national law under martial law in the Philippines then, which remains now the current National Building Code, the 1977 Presidential Decree number 1096. Many big disasters have happened since then. Involving the collapse of buildings. Preventing or reducing the collapse of buildings remains a big socioeconomic goal. Indeed, buildings are meant to shelter people, not to harm them. A World Bank global report in 2015 quantified an empirical argument for improving building regulations. 47% of disaster events may possibly associate with reduced fatalities of only 7% of all those disaster-related. In 2016, our national agency that is primarily in charge of regulating public and private buildings requested a review and study of the National Building Code and its implementing rules and regulations for recommendations of comprehensive improvement. Our university, the University of the Philippines, through our National Engineering Center and our Law Center, facilitated the technical and legal research. We listened and listened to long-standing concerns from the past years and decades, such as unfair legal arrangements, ineffective administrative arrangements, outdated technological arrangements, including conflicts among other laws like the Fire Code of the Philippines or the Local Government Code, examples of legal issue, including contradictions among government offices, example of administrative issue, including hazards that are scientifically less understood yet, and materials or methods that are technologically less familiar yet, examples of scientific and technological issues. More than 400 other stakeholders contributed, coming from private sectors and government agencies. Debated were literally dozens of major issues and hundreds of provisions. The legal and technical review used several modes of study, including a study of international practices. Among the issues noted were concerning the Fire Code of the Philippines and the National Structural Code of the Philippines. Here, 3 issuances are all called codes with unclear hierarchy among them. An issue with the Fire Code is, as stated at the lower left, the prescribed minimum width of aisles for egress, which was quote-unquote hard-coded into the NBCP. It's in conflict with the IRR of the Fire Code of 2008. Also, the IRR between the two codes are in conflict in some aspects. For example, the prescribed minimum height of firewalls above the roof. An issue with the structural code is the requirement of peer review of certain special structures. It is not well provided in the NBCP, but it is prescribed in the NSCP. Overall, among the major concerns that emerged are the following: the building permit process being either too outdated or too vague and therefore too discretionary, the design of buildings being unconscious of multiple hazards, old buildings being orphaned by the professionals after 15 years, the retrofit of old buildings being a legal, administrative, and technological dilemma, what to do about it, the Interagency and Multisectoral Council to review and update every 5 years or sooner, that's been needed since yesterday. Even after our study, regulations and standards for buildings have been put in question time and again, nationally or locally, legally, administratively, or technologically. For example, in this region in Mindanao of the southern Philippines, several months ago, 3 significant earthquakes shook the site in a short span of 2 weeks. Is it right that the building on the right has collapsed while the building on the left is left standing? And now in the time of COVID-19, now also the time of tropical storms, floods, landslides, do we have to wait for this kind of perfect storm, literally, before we act? Actually, the Philippine Development Plan 2017 to 2022 includes the mainstreaming of disaster risk management into our infrastructure. In fact, the National Economic and Development Authority, our national planning agency, agrees that it's time, even overdue, to reform the framework and be more responsive to issues and developments currently. In fact, issues and developments that are emergent and emerging. We have studied some framework examples from other Pacific Rim economies, such as New Zealand, also Japan, and a few more. We observed that our long-standing concerns in the Philippines are so pervasive that we need to reform the framework itself that barely holds everything together. Part of the so-called problem in the Philippines is the multiple usage of the term code without clear hierarchy. The comprehensive reform would start with a new Philippine Building Act. The comprehensive reform certainly would not end there. It would reckon with other coexisting laws. Administrative regulations and technological standards would have to follow in a more innovative manner. This is now a priority by the Congress of the Philippines to reform legally, meaning fundamentally. It needs to be also a reform and innovation in administration. It needs to be also a reform and innovation in technology, or even a technological revolution. Legislate major reforms. That is the jumpstart that we need now in the Philippines. We urge and support the Office of the President to certify the proposed Philippine Building Act of 2020 as urgent for the improvement of our buildings, structures, and houses, our most basic of social infrastructure. We urge and support the House and the Senate, the 2 chambers of the Congress, to approve and co-implement after reforming the system of regulations and standards for various types of public and private buildings in the country, proposed, existing, or old. We thank many representatives in the previous 17th Congress and in the current 18th Congress for their bills and resolutions. We thank our senators too. Convinced by previous comprehensive studies and consultations, our national lawmakers are enacting major legal reforms. First among those is to streamline the building permit process. Then design buildings to be more resilient against multiple hazards, including evacuation buildings. To assess old buildings every 15 years. To incentivize retrofit of old buildings. To create the Interagency and Multisectoral Building Regulations and Standards Council to review and update every 5 years or sooner. We need to make the process simpler for simple buildings. We need to apply the additional process of peer review to special buildings only. We need to make even more transparent the regular process of regulation for regular buildings. What do we find at the bottom line of these major reforms? We find that the newly introduced BRSC, Building Regulations and Standards Council, will be the legal springboard for more objective and collaborative building care. So, after the jump start by the legislative, a marathon awaits the executive. Execute partnerships that will have to be the grand scheme among all of government. We urge and support the various government agencies, particularly the Department of Public Works and Highways and the Department of Interior and Local Government, and private sectors to engage partner government agencies and private sectors in crafting and updating periodically the regulations and standards for buildings, mainstreaming disaster risk reduction and management, including, among others, the Department of Science and Technology. In fact, private sectors too. And collaborate in the compliance and the enforcement. That will have to be the social contract between the governed and the government. We urge and support the various government agencies, particularly the Department of Science and Technology and the National Economic and Development Authority and private sectors to collaborate across agencies and sectors in the compliance with building regulations and standards and the enforcement of the same, infusing with research and development in particular, and a culture of science, technology, and innovation in general. Some may choose to pinpoint who are the few who are responsible, but with the reform under the proposed Philippine Building Act, many will have to share responsibility. The corresponding liabilities are to be reasonably proportionate too. That is why the new BRSC Standing Council will engage not only government regulators and officials, but also private proponents as listed here, joined by academics, educators, and researchers, because regulations and standards must benefit from advancing knowledge, skill, and attitude. They're joined also by representatives at large because buildings, structures, and houses are a public concern, being our most basic social infrastructure. Is there room for science, technology, and innovation in this most basic of infrastructure? Both social science and natural science? Yes, there is. not just a room, but a whole building. The challenge continues for affordable safety, security, health, and comfort. The challenge continues on the many concerns that we are addressing these days, including, for example, information and communication technologies, ICT. The challenge continues. For example, as ICT becomes ubiquitous more and more, there are many technological reforms that can improve all or most of our buildings in terms of basic documentation, or BIM systems as reference for maintenance, or instrumentation and virtual twin digital monitoring in real time or near real time in future. In summary, after 43 years of history of nationwide regulation of buildings, we in the Philippines need major reforms in order to reduce mortalities, economic losses, and social infrastructure disruptions. 5 major reforms and numerous others are geared towards balancing regulation and innovation while aiming for sustainable development. Globally, I believe that our respective economies need to join together in infusing the regulations and standards for shelters, that is, buildings, structures, and houses, with a culture of science, technology, and innovation. So today, thank you for joining. I look forward to more discussions with all of you. Good day.
Thank you very much, Professor Pacheco. Due to that, the instability of the network, so that he kindly pre-recorded his wonderful presentation. Thank you so much, Professor Pacheco, for joining us when you are very extremely busy. So we have a couple of questions. So firstly, very, very in general, a question from Bangladesh. And we know that building code is very important for all. But those people who live in the modern slum, like those infrastructure which are built closer to closer, what about their safety? So is there anything you also that they can do?
Well, thank you for the question. And first of all, Professor Izumi and all our audience, I'm glad to see all of you, of course. And yeah, we're all sheltering from home. Yes, even in the Philippines or in many developing countries, we are aware there are many we call informal or non-formal shelters. The proposed building act that we are talking about today includes, of course, some innovative social approach, how they may be included also in what we call simplified regulation. And it may be said that the urban poor, for example, in my country or in other countries, they may not have a lot of attention paid to building regulation. But this time, this Philippine Building Act, the point of view is joint effort by the government or the government sector, as well as the private sector, to come up with, well, simple structures maybe, but simplified regulation too. So I guess one change in our approach is not to forget about informal or small shelters in the urban areas, but in fact to include them in a simple or simplified, easy to follow way rather than ignore them. So yes, they are a very real concern. We're thinking here of not only the big structures or buildings, but yes, the small shelters as well.
Okay. Thank you very much for your answer, Professor Pacheco. One more question, particularly in the Philippines. So what are the main challenges of reforming the legal framework of building code in the Philippines?
Well, thank you for that question. The challenges may be technical. The challenges may also be administrative, as you know. I will give 2 examples. in the Philippines, in terms of administrative challenge, you know that the Philippines is an archipelago. We have many islands, and since the 1980s, we have adopted a local government code that allows some or a lot of autonomy of the local governments, so that there may be a national building act, but we imagine or we use a local implementation. So one challenge is after you have adopted or after you have put together a national regulation or national law, how do you operate this in the cities or towns? So the training as well as the giving of resources or even manpower, enough resources for the local governments to implement the national regulation in a nice or consistent way, that's an administrative challenge. Technical challenges we also have as well. As you may have heard from my presentation, in the 1970s, the law that was made at that time tended to be prescriptive, meaning it tells you what to do, how to do, like a cookbook. But as you can guess, after 40 or 50 years, a lot of technologies or even the economic situations have changed. So the technical approach has to change. So the technical modernization or innovation is also a challenge. So we're trying to solve both problems, administration as well as technical innovation. And I mentioned in my presentation, one ingredient or one part of the formula is to make sure that there is a multi-sectoral and multi-agency council that regularly, periodically looks into the technologies, look at the economic situations, and every 5 years, make sure that the standards and the regulations are made up to date. So keeping up to date is always a challenge, right? In any country or in any economy.
Definitely. Yes, thank you, Professor Pacheco. And I think there are more questions about the building codes, in particular the situation in the Philippines. So another question is that how do we motivate or incentive local government units to strictly implement building code and zoning regulation policies in cities and municipalities?
Yeah, to give the incentive to the local governments, it's a political approach, of course. It is one approach in our Philippine Building Act that the citizens in the towns and the cities, they are aware that they must be aware, they must be made to be aware of, for example, comprehensive local use, land use plans of the local governments. They're also made aware that the implementation of this kind of building regulation is in the hands of the local officials. And also, even in terms of giving credit to the success of local implementation of the Building Act, that is clearly in the hands of the local government. So I think the education and awareness of the people, of the citizens, that our local officials, they are the ones who are really able to implement these, and therefore we should cooperate with them. I think that's a good motivation or incentive to local government. So in summary, I think we're saying, even if the law is national, very comprehensive, but it also says that the implementation must give credit to the local government, and therefore the citizens should follow the local implementation. So local government autonomy, I think, is a good incentive for our local officials, the mayors, to make the law, the regulation effective.
Yeah, indeed, it is very important for all the stakeholders to work together, and also the leadership of the government is definitely important, and both national and local government as well, I think.
Yeah, and the architects and the engineers, they have a local face. They are known to the city or the town, so that gives, I guess, a personal approach that it's not like the citizens or the building owners are following only on paper. They know who to speak with, the architects and engineers in their own town and cities.
Indeed. Okay. All right. Okay. So in your presentation, you also mentioned about the contribution from academia and also the science, technology, and innovations, how we can contribute to the, this kind of regulation. So one of the question is that, what cost-effective and IEC solutions are available to change the current situation in terms of the building code and also the change of the strengthen or improving the regulations?
Okay, it's a good question, like how people in the academia are able to contribute. Uh, in general, I can give an answer and also a specific answer. In general, a good answer or a good role for academia to help is we keep our research into technologies as well as our research into the economics of new materials or new methods. We make those known to the private sector so that owners of buildings, even in the private sector, of course, also the government sectors, are made aware of the new options that are becoming possible, not only being safe and efficient, but being economic as well as sustainable. We are paying a lot of attention, of course, in research nowadays, not only to building or construction materials that are they call cost effective or efficient, but yes, sustainable in the long run. I could also say that the academia is able to contribute more specifically. For example, we join in, for example, our own University of the Philippines group is an example. We help the government as well as the private sector to make an analysis of current or existing buildings and give practical advice how retrofitting might be prioritized, because it's a big social problem, as you know. All the existing buildings, whether big or small, they were legal from the start, like 30 or 40 years ago, but after technologies have advanced and science has advanced, we feel that some of them may need assessment and retrofitting. So researchers are able to assist the private sector as well as the government sector so that retrofitting, assessment and retrofitting can be made more practical. So yes, there's room for researchers to help so that not only individual building owners have to think about their separate buildings, but the whole community can think about the building stock as a whole.
Okay, all right, okay, yeah, thank you so much. It's really encouragement for us. There are so many things we have to work on. So probably this will be the last question for you. And now we were talking about technology and also the science things, but rather one thing is that about the old setting houses. One question is that, is there, sorry. Okay. Sorry, there was one question about the old, the building and, sorry. Okay, one question is that, does the new law addresses the concerns about the old building safety against risks, particularly major earthquakes?
Yes. I must emphasize the old or the present law does not address existing buildings, but yes, the new law makes sure that if the building or buildings are more than 15 years, we must realize that the legal responsibility of the professionals, the architects and the engineers who were originally involved with them may have already stopped. But with this new law, the government is encouraging, giving some incentives, administrative incentives or even financial incentives, so that owners of the older buildings will start assessing their old buildings, and also the government would assist in making some retrofits when retrofit is deemed to be necessary. So I must say, one of the, or two rather, of the 5 major legal reforms, they are really targeted to old buildings. We're so worried that buildings that are still there from 60 years, 50 years, even 20 years, have to be reviewed or assessed and have to be supported for some interventions in case they are found to be not quite up to the present standards. So yes, we care about our old buildings so much.
Yeah, that's great to hear. And old houses are also included in new laws. Yeah, thank you so much, Professor Pacheco.
Thank you too.
Although we had so many questions to you, But unfortunately, it's limitation of the time constraints. So unfortunately, we cannot take all the questions. So we can probably provide these questions to you later on, and you can answer those questions by email or something.
We'll be happy to answer by email. Thank you, Professor Izumi.
Thank you so much. And once again, you also recorded and in advance for the presentation and your kind cooperation. Thank you so much, Professor Pacheco.
Thank you.
Okay, thank you. Okay, so now I'd like to introduce the second speaker. And again, due to the instability of the internet access, the next presentation is also the pre-recorded, kindly pre-recorded by the speaker. So now I'd like to introduce the next speaker, Professor John Randall from UC Davis. And he is a distinguished professor of physics and earth and planetary science, University of California, Davis, and executive director emeritus of the APIC Corporation of Earthquake Simulations, and a visiting professor at Tohoku University in Sendai, Japan. In addition to natural hazards and earthquakes, he also has professional interests in forecasting, validation of forecasts, and quantitative finance. He teaches courses in risk and natural disasters, complex systems, and econophysics and quantitative finance at the University of California, Davis. He is also a core group member of the APRU Multi-Hazards Program. Okay.
Our motivation In this lecture, we'll be talking about forecasting and nowcasting earthquakes and tsunamis using the methods of machine learning. This is a very important focus in our group here at the University of California, Davis, and one we plan to work in substantially in the near future. The motivation for our work comes from great disasters like this one. This was the earthquake and tsunami of March 11, 2011, along the Sanriku coast of Japan. In the upper left corner, you see the tsunami coming through the trees, which were planted by the local lord Date Masamune in about 1600 AD, precisely to guard against such tsunamis. In the lower right corner, you see the tsunami, the water, beginning to engulf the airport in Sendai. We'd like to know, how do we anticipate these risks? How do we estimate their effect on the insurance industry? And we want to know how people can prepare for these things, and that's why we want to forecast and nowcast these events. So what is forecasting and nowcasting? Forecasting is the probability of future activity in the earthquake cycle. We want to calculate the probability of a future large earthquake. We need to estimate the time, location, and magnitude of the event. And nowcasting describes the current state of the hazard cycle, so it's different. It was first used to describe the current state of the economic and business cycle, and then later used in weather and climate applications. What is machine learning? Well, it's an application of artificial intelligence. It provides systems, computers, the ability to automatically learn and improve from experience. Machine learning focuses on the development of computer programs that can access data and build models of the process. Machine learning aims to learn patterns in past data to predict future data. It's commonly used in many data science applications, including advertising in Google, Amazon, Facebook, and other large companies. The reason is because when you go to buy something or look for something on one of these websites, you don't want to have to go through millions of web pages to find what you want. So what machine learning and AI do are build models of you that record your interests so that the website can show you things you might be interested in. There are several very sophisticated machine learning libraries that are now readily available on the web as open source applications. So these machine learning goals are supervised learning and unsupervised learning. The specific goal is a program that performs as well as humans for supervised learning. And for unsupervised learning, it really just wants to find structure in the data. The task that supervised learning tries to do is to compute a target function to constrain the results. It's a well-defined process. Unsupervised learning, on the other hand, only tries to find structure in data, so it's not well-defined or even could be undefined. In terms of past experience, the training data set is provided by a human, but for unsupervised learning, none is supplied. For supervised learning, the performance can be judged with error and accuracy with respect to the task, whereas for unsupervised learning, it can't be evaluated. Subcategories for supervised learning include classification and regression, that is, to fitting lines to data, whereas unsupervised learning, the typical examples include clustering and dimensional reduction, which includes feature extraction and feature selection. So these machine learning methods are based on defining labeled feature vectors. The labels are target variables for each feature vector. The typical feature vectors are statistical quantities characterizing the system, such as the mean, the variance, the kurtosis, things like that. Labels could be 1 for the presence of some desired characteristic in the data and 0 for its absence. So, for example, if you're trying to predict earthquakes, the label 1 could mean that there would be a major earthquake during the next year, and the label 0 could mean no major earthquake during the next year. So, as I mentioned previously, there are a number of open source libraries that can be used for machine learning purposes. These are scikit-learn for classification and regression, TensorFlow for neural networks, including deep learning. Deep learning is just a variation of neural networks. PyTorch, which also has libraries for deep learning, and Keras. On the lower left corner, you see an example of an artificial neural network. Data is fed in from the left, and the output on the right is the computed target label in the data. Between the input layer and the output layer, there could be several hidden layers. These hidden layers are arranged in groups called perceptrons. The type of network you see on the lower left is called a feed-forward network because things go from left to right. There's no feedback loops. On the right side, you see what's an example of a decision tree that comes out of the scikit-learn application. In this case, we've started with some data and we've computed some patterns, which are called eigenvectors. And then we want to classify these in terms of this tree-like structure. What we're going to do is to use a training data set to build such a classification. And then we'll use a test data set to see how well it operates. In the end, the goal is to take data with no label, classify it according to this scheme, and then predict a label for that data. In terms of the workflow for nowcasting and forecasting with machine learning, typically what we do is we download some global data. We build a cloud-based computing engine based upon PHP code and MySQL code, store it in a database, and then this data is converted into labeled feature vectors, which go into some machine learning libraries, and out come some predicted labels or some target variables. The automated machine learning algorithms involve, as I mentioned, the training and testing of labeled feature vectors. The new label that we compute from the future data implies a forecast for future data, and the result would be predicted labels for future unlabeled feature vectors that arise from new data as it is acquired. As an example of the kind of problem we're looking at, This slide shows the earthquake cycle in the Nankai Trench in southwestern Japan. Data comes from Masataka Ando's paper in 1975 and is based on data from historic writings in Japan. The basic idea of the cycle, which started in Japan, this idea started in Japan, is that there are a series of earthquakes, major earthquakes, that occur in time separated by perhaps 100 years. On the right-hand side of this figure, you see the same region of southwestern Japan, the coast of southwestern Japan, and there are 4 regions, A, B, C, and D, that apparently historically have broken as major earthquakes. Each of these major earthquakes has been greater than magnitude 8. The most recent such earthquake was in the Nankai Trench in 1946, and there is significant concern that the next earthquake will be on this section D called the Tokai earthquake. That hasn't happened yet, but the fear is that it will happen in the not too distant future. The earthquake cycle was also considered in 1906 by Harry Fielding Reid. He was a seismologist who was in the California earthquake investigation of 1906 for that earthquake, and he proposed the idea of what is now called elastic rebound. That is to say, the tectonic stresses build up on the fault, as you see in the upper part of the figure, and at the time of the earthquake, they're suddenly released by slip. So the fault slip increases in a kind of stair-step way, while the fault stress increases as a kind of sawtooth function like that. So a group at Los Alamos National Laboratory, including Rouet-Leduc et al., published in 2017 and 2019, decided to build a model fault in the laboratory. So they took 2 blocks of rock and arranged an experiment where one block of rock would slip on the top of the other one. So you saw a stick slip in the upper left part of the figure on the right there. The slip would build up over time, the stress would build up, the forces would build up over time, just as you saw in Reid's idealized version. And then there would be a sudden slip event with the associated emission of small earthquakes, if you will. So in the laboratory experiment, one talks about acoustic emissions. These are small bursts of sound energy, acoustic energy, that accompany these small slip events. Using a sliding window shown in the lower left corner there of the figure, they defined some of these statistical properties of this acoustic emission signals. And then what they did was they used something called the random forest classification technique, which is similar to the decision tree that I showed earlier. Using this random forest technique, they were able to classify these statistical variables and show that they could predict the time of slip of the 2 blocks of rock. And you see the superposition on the lower right, slide D there, of the predictions and the testing data. So this experiment in using machine learning to predict slip in the laboratory was apparently rather successful. They then decided to apply it to the Pacific Northwest of the United States. Here, one finds an interesting phenomenon called episodic tremor at slip. What's happening there is that on this fault zone, a subduction fault zone, similar to what you see in Japan, there are now periodic slip events separated in time by about 14 months. Associated with these slip events are the burst of small earthquakes. So this setup is very similar to the laboratory experiment that they did, and they were able to apply their machine learning technique and show that in fact it worked pretty well. What we'd like to do is to apply a similar method to the coast of California. Here in this slide you see the major earthquakes that have occurred since 1980 along the west coast of the US, Mexico, and Canada. Unlike Cascadia, these events occur irregularly in time, and they don't show the periodic patterns that you saw in the laboratory in Cascadia, so the problem is much harder. Nonetheless, we'd like to try and apply some of these machine learning techniques to that situation. So one thing we can say is that the small earthquakes in California occur in bursts. These small earthquakes can be either called aftershocks or called swarms. They differ in that an aftershock is a series of small earthquakes following a major large earthquake, whereas the swarms are a series of small events in which there's no large main event. So what we did was to use machine learning classification techniques to show that the size of these bursts vary systematically in time prior to the large earthquakes. On the right side of the slide, you see a plot of the number of small earthquakes in 1-hour intervals from 1992 to 1995 in the Mojave Desert region of California. You can see the Joshua Tree earthquake, which was a magnitude 6.1. That event occurred on April 22nd, 1992, and was accompanied by a small decaying set of aftershocks. Then the large Landers earthquake occurred, magnitude 7.3, on June 28th, followed by many small aftershocks. And then the Northridge earthquake, the magnitude 6.7 earthquake that occurred north of Los Angeles on February 17th, 1994, also spawned many small aftershocks. So what we did was to take this data on bursts and analyze it in the following way using these machine learning techniques. We showed that we could define bursts, we could classify the events into bursts that we saw in a region of size 600 kilometers around Los Angeles. Our data showed that the radius or the size of these bursts of small earthquakes decreases with time prior to the magnitude 7 earthquakes. You see that in the slide on the right, the picture on the right. So what we're seeing on the right is a series of large earthquakes denoted by these red dashed lines: the Landers Big Bear earthquake, the Hector Mine earthquake, the El Mayor Cucapá earthquake, and the Ridgecrest earthquake, all magnitude 7 earthquakes. You can see that the radius of these bursts, what's called the radius of gyration, decrease systematically with time leading up to these major events. And then at the time of the earthquake, due to the sudden burst of aftershocks, the radius of the small earthquakes bursts increased dramatically. So this looks very much like the increase of stress prior to tectonic stress prior to the big earthquakes, and the sudden release of stress during the earthquake itself, and then a recovery leading up to the next large earthquake. So the vertical red dashed lines again are the magnitude 7 earthquakes. The vertical black dashed lines are the still large earthquakes between magnitude 6 and magnitude 7. Most of these black vertical dashed lines are unlabeled. So getting back to the idea of nowcasting and forecasting tsunamis and run-up, the picture here shows the Great East Japan Tohoku earthquake and tsunami of March 11th, 2011. We'd like to provide an estimate of risk from such major earthquakes and tsunamis, both long-term in the months to years time frame, as well as for early warning, that is to say in the 10 minutes to tens of minutes before the tsunami strikes the coast, but after the earthquake has occurred. So for this, we need not only an earthquake model, but a tsunami inundation model as well. So to proceed on this program, what I show in this slide here is tsunami source regions for great global earthquakes bigger than magnitude 7.9 since 1900, and you see a series of these around the Pacific Rim. Some of the more recent ones are those in Concepcion and Valdivia in Chile, the Sumatra earthquakes, north and south, that occurred following 2004, the Tohoku earthquake, which occurred in the Sanriku coast, and in the Aleutians and so forth. What we'll be looking at in the next slides are the Sanriku coast source region, denoted by the white arrow. This is the section of fault which broke on March 11th, 2011. So in our nowcasting technique, what we do is we have built a histogram of small earthquake numbers. That is to say, we record the numbers of small earthquakes between the large earthquakes, and these are denoted by the vertical green bars. If we find the cumulative distribution function of the small earthquake intervals, that is to say, we accumulate these small intervals and turn it into a curve that turns out to be this jagged red curve that progresses from lower left to upper right, that is a statistical variable called the cumulative distribution function. So what we can now do is count the number of small earthquakes since the last large earthquake, which was on March 11, 2011, and define something called an earthquake potential score, earthquake potential score. So the current score is 24.6%, which means that between all the great earthquakes, bigger than magnitude 8, the San-Riku source region has progressed about 25% of the way through its characteristic earthquake cycle. So the implication would be that the current risk of another magnitude 8 earthquake in this region is fairly low, 25%. So what we'd like to be able to do, again, is to take those kinds of intermediate level warnings, and once a major earthquake occurs, we'd like to be able to provide substantial early warning of the event hitting the coast, of the tsunami hitting the coast. So the way this is anticipated to be done is we collect and process high-rate GPS, or Global Navigation Satellite System data, estimate the earthquake magnitude and location within a minute, then find the model fault that did it, and then predict the ground displacement and the tsunami that will lead to potentially deaths and damage along the coast. So one of the ways we can simulate this was with a method called tsunami squares. This is a simulation method that can be used to compute coastal run-up and inundation, as well as basin-wide tsunamis. We have developed such a method, and you can see it in the movie on the right occurring, inundation of the coast of northern Japan, near the Sendai area. We also, of course, want to verify how accurate it is, so we compare it to data as well as to existing simulations, the regional ocean modeling system of simulations. And our comparison is fairly good. It's not perfect, but it's fairly good. We can also do basin-wide simulations by the same tsunami squares method. And here you see, again, the simulation of Tohoku tsunami as it's generated off the coast of Japan and then propagates across the entire Pacific Basin, along with reflections from the coast of North America, as well as inundations of South America. Interestingly, you can see that Hawaii gets hit by the direct wave as well as by the reflected wave from North America. In summary, what we've discussed in this talk are great earthquakes and tsunamis which present major risk to populated regions. We're trying to anticipate these events by means of forecasting and nowcasting. That's an important problem. The modern way of approaching this is using machine learning, which represent a series of promising tools for advancing the science of prediction, forecasting, and nowcasting. Early warning depends both on advances in models and technology, and that's another type of activity that we would really like to be able to make progress on so that we can save lives and property. Thank you for your attention.
Thank you very much, John, for your presentation. Very fascinating nowcasting and forecasting for tsunami and earthquake. And thank you for your active participation for the multi-hazard program since the beginning. This is the 8th, and you have been participating 8 summer school. So thank you so much for your support. Okay, so we have quite a lot of questions for you. And first one is that, okay, let me see. First question is that what are the main challenges that MI faces to effectively forecast earthquake, particularly in the region where historical data may not be so abundant?
So this is a major problem. In many applications of machine learning, one has not only access to the patterns of activity, but to the underlying dynamics or physics that drives the activity. As an example, in weather forecasting, you can actually take pictures of advancing clouds, weather fronts, hurricanes, like the one that's about to hit the United States. Unfortunately, with earthquakes, earthquakes are driven by stresses in the earth. And there's really no way to image those stresses with any sort of remote sensing type technique. The best we can do is to look at surface deformation with a variety of techniques, such as the Global Navigation Satellite System or synthetic aperture radar from space. And we also have, of course, the events themselves, the earthquakes themselves. What we don't have are the forces and access to the underlying equations that govern this process. So we have a very incomplete data set. However, we can, I believe, make progress, and we're just at the beginning of that. This has not been tried very often as yet. The paper by Rueda-Duc, that work is the really the first relatively successful example of this sort of thing. But there is substantial promise. I can't say more than that at the moment, but the advantage of artificial intelligence and machine learning is that it gives you access to methods to try to understand these highly complex, high-dimensional systems that a human mind simply would have difficulty trying to comprehend. We like to build, in the past, we'd like to build simple models, but simple models aren't good enough in this case. We need a method, which is the machine learning method, which allows us to basically integrate thousands, millions, tens of millions of data points and come up with some sort of integrated, holistic approach to this problem. So that's about all I can say at the moment.
Okay, thank you, John. So in relation to that, is there anything AI can do to reduce that kind of challenges, you think?
So AI has the advantage that as computers get faster and better, and as more data becomes available, we will be able to do better. So it's anticipated that within approximately 10 years or so, our ability to deal with these problems is going to increase exponentially. One example is you can imagine Google Translate, which I use frequently when I'm in Japan. I have it on my phone, my iPhone. A few years ago, that didn't exist. And for me to get around in Japan was a little difficult, although there's more and more English in Japan right now. But now with Google Translate, which, by the way, was developed using what's called a neural net. I can talk into my phone and it can translate it essentially instantaneously, and it'll come out in Japanese and vice versa. So we can actually have a conversation using Google Translate that simply was not possible before. And that was made possible by the advent of neural networks.
Okay, yeah, thank you so much. So another very interesting and important question is that how do you think can the insurance industry benefit from forecasting and nowcasting?
So the insurance industry wants to have a better handle on their risks so they can improve their pricing and their profitability. The better the forecast, more accurate the estimate of risk will be, and the higher the chance of saving significant lives and property. So I recently gave a talk about a year or so ago at an insurance industry conference, and they were very keen to understand how they could develop better risk estimation and forecasting techniques. It goes directly to their bottom line. So they are extremely interested in this topic.
Okay. Then there are more, some of the very technical questions, I think. What are the main differences between your method and W phase model? Is it possible to build a mixed model?
So the W phase model is a seismological method where they look for the W phase of an earthquake, which is the phase which is developed over probably 10 minutes from the actual earthquake. At the present time, tsunami early warning has a delay of probably 10 to 20 minutes, which, as you know, in the Tohoku earthquake, there was a major problem in that people didn't receive warnings early enough to take action. What we anticipate doing is with high rate GPS observations, GNSS observations along the coast, and there's something like 10,000 stations that are located around the Pacific Rim at this time. We could actually develop a model of the earthquake within probably a minute. And given a library of simulations, we could then estimate from that model of the earthquake what the likelihood of inundation of the coast would be in a matter of probably 2 or 3 minutes, thereby giving a substantially more warning, more lead time to people along the coast that would allow them to take action.
Okay, thank you, John. Then we have a couple of questions about accuracy on that prediction. So please give the idea how to get long-term predictions and how accurate it would be, and how accurate machine learning methods can predict the earthquake.
So this is an interesting question. Thanks for the question. There are several well-known techniques. One is called receiver operating characteristic, and another is called reliability or attributes. Either one of those things, both of those things, develop statistical methods of accuracy and error. In the example I showed, René Leduc and his colleagues, basically they were able to show that in their prediction of the laboratory earthquakes from sliding rock, blocks of sliding rocks, that they were able to achieve a prediction of the onset of the next major sliding about 90% of the time. In the Pacific Northwest, it's an easy problem. It's an easier problem than in California, for example, a much easier problem because these little events, these slip events happen every 14 months or so. They were able to achieve almost that a good an accuracy. I think it's probably about 80 or 85%. So there is some cause for hoping that we can do pretty well. When one does these kind of classification techniques, one of the things one develops is what's called a contingency table or a confusion matrix, which allows you to estimate the number of successful predictions, forecasts, the number of false alarms, the fraction of false alarms, and the fraction of failures to predict. So you can give some kind of statistical estimate to a user of how accurate your method is likely to be.
Okay, thank you, John. So this will be the last question. Since you are also doing early warning, tsunami early warning, and that kind of things. So is there any idea or technique you think to be applied for other disasters? For example, like tsunami, not only tsunami, but flood and other typhoon and for other disasters.
Well, since I haven't really studied those other disasters, I probably shouldn't say. It would be just me commenting on out of a sense of probably ignorance. But I strongly suspect that all of these kind of techniques we're exploring would be highly useful in other disaster applications as well, given a significant amount of data.
Okay, all right. Okay, so once again, thank you so much for your fascinating presentation, and I hope we can continue working together for summer school and other events in Multi-Hazards Program. Yeah.
Thank you.
Thank you so much, John. Okay, so now I'd like to introduce the last speaker for today's session. and Dr. Rianti Jojolante from United Nations University, Institute for the Advanced Study for Sustainability. She has over 10 years of scientific research and international professional experiences in the field of development, governance, disaster risk reduction, climate change adaptation, resilience, and vulnerability. And her international work experiences encompasses in Indonesia, Southeast Asia, Australia, Japan, Germany, and Netherlands. And she supports policy relevant actions for the Sustainable Development Goals, Sender Framework for Disaster Risk Reduction, and the Paris Agreement on Climate Change. And her current appointments include the member of the Scientific Committee of the IRDR, Fellow of the Earth System Governance Network, Social Science Fellow of the International Council for Science. So thank you so much, Rianti, for joining us, and I really look forward to your presentation. Thank you.
So please allow me to share and also start my video. Okay, so
this is the story of how one species changed a planet. The latest chapter of our story begins in England 250 years ago. Fueled by coal, then oil, several brilliant inventions appeared. They ignited the Industrial Revolution, which spread like wildfire through Europe, North America, Japan, then elsewhere. The great railways, then cars and highways, connected people across the globe. Medical discoveries saved millions of lives. New artificial fertilizers meant we could feed more people. Population rose rapidly. But this was nothing compared with what was to come. The 1950s marked the beginning of the Great Acceleration. Globalization, marketing, tourism, and huge investments helped fuel enormous growth. People swarmed to cities, which became even more powerful engines of creativity. In a single lifetime, the well-being of millions has improved beyond measure. Health, wealth, security, longevity. Never have so many had so much. Yet 1 billion are malnourished. In a single lifetime, we have grown into a phenomenal global force. We move more sediment and rock annually than all natural processes, such as erosion and rivers. We manage 3/4 of all land outside the ice sheets. Greenhouse gas levels this high have not been seen for over 1 million years. Temperatures are increasing. We have made a hole in the ozone layer. We are losing biodiversity. Many of the world's deltas are sinking due to damming, mining, and other causes. Sea level is rising. Ocean acidification is a real threat. We are altering Earth's natural cycles. We have entered the Anthropocene, a new geological epoch dominated by humanity. This relentless pressure on our planet risks unprecedented destabilization. But our creativity, energy, and industry offer hope. We have shaped our past. We are shaping our present. We can shape our future. You and I are part of this story. We are the first generation to realize this new responsibility. As the population grows to 9 billion, we must find a safe operating space for humanity, for the sake of future generations. Welcome to the Anthropocene.
Yes, so good morning, everyone. I think I would like to say thank you to APRU and Tohoku University for allowing me to give my second or third lecture for this APRU Summer School. And also greetings to everyone. It's nice to see a lot of familiar names as attendance for this summer school. So I'm giving my title of the presentation, Global Impacts of Disasters and Climate Change and Recent Advances in Disaster Risk Reduction Science and Policy. This is UNU. We are spread along along 12 countries and 13 institutes. UNU Center or Rector Office is based in Tokyo, and I'm based at UNU IIS in Tokyo as well. So I divide my presentation into like three major parts. First, we will discuss global disasters and climate change risks. Then we moved into the science and impacts of climate change. And also, I think the last one, international frameworks for disasters and climate change. So we have seen the video of the Anthropocene. So I think three major or concepts that I would like to introduce. So we see you have seen the video of the Anthropocene. This is, we are entering the era by which human has changed the natural physical system of the earth, which then influence our societal system now and in the future. We are also, another keywords that you have heard is called this, the Great Acceleration. So socioeconomic trends and Earth system trends are all accelerating. Population increases, we are getting healthier, we are getting wealthier. However, of course, we are getting more unequal. Poor people get poorer, but rich people get richer. Also, the Earth system trends increases as well, which then move us to this third concept of planetary boundaries. Stefanov et al. In their study in 2015 proposed 9 planetary boundaries, which you can see here as in the first figure. There is a circle which called safe operating boundaries for humanities. And for climate change, for example, it's 1.5 to 2 degrees. We have seen here boundaries such as biochemical flows, so the use of phosphorus, nitrogen have been passed. Genetic biodiversity, or in terms of risk to global biodiversity, have been passed as well. Climate change, fresh water is increasingly under pressure, and also there is this introduction of novel entities, something that we don't know yet, but of course we will know as we have more science develop. So this global environmental change, or within these three factors, will of course influence how disaster risk and climate change will actualize now and in the future. So this is the World Risk Index developed by our colleagues institute in Bonn. So we have seen here the regions of Asia and Africa are considered high and very high in the index. Immediately, of course, one thing that we can take from here is that reducing disaster risk is strongly related to development. So meeting development needs, effective development, risk-based development is necessary in order to reduce risk. This is also, again, global disaster impacts. There are 4 ways by which disasters are measured. I'm sure like many of you, or maybe all of you are familiar with this. I get this statistic from MDAT. So in terms of numbers of disasters, the frequency of disasters has increased. And you see from the video that I showed in 1950s, coincide with greater development, urbanization, increased population. We also see the frequency of disasters increase. However, after 90s, the 2000s, like it's slightly reduced. This also shows that our global, national, and local effort for risk reduction indeed works or helps to reduce the frequency of disasters. In terms of number of deaths, the trend increases overall. However, I think we see sudden increase in the number of deaths due to, of course, like earthquake and tsunami, and mostly occur in Asia. The third figure that we see here in terms of number of total affected, and this is very important, flood affects the highest number of people, and it's expected that it will continue in the future. And we know climate change affect the frequency and severity of disasters, so that we expect that total number of affected will also increase. And also the economic damage. The trend is also similar, starting from 1950s, 1960s, as we start to collect data on the economics, the figure or the number of economic damage, or statistic on economic damage is increasing. What if we put these statistics and comparing geophysicals and climatic disasters? So we see that in terms of climatic disasters, so flood, typhoon, drought, extreme weather events dominate the statistic. 90% of the occurrences in terms of 2/3 of the total affected, more than 90% of the total damages. We see that climatic disasters dominate, except in the total number of deaths. So it's very important that this integration of disaster risk reduction and climate change adaptation needs to be done from now on. I think this is also a figure that is very interesting. We see here in terms of the total affected. In the past, Africa has like a displacement in Africa tend to be caused by conflict. However, we see now conflict and disasters are starting to collide. And in Asia, especially Southeast Asia, disasters are almost affected completely by disasters. So it's important that we need to also address these displacements by conflicts and disasters. What has the Global Risk Report tell us? This is the latest one published by World Economic Forum. In the past, economic, societal, geopolitical, and technological risks dominate the landscape. But now we know that environmental risk, here extreme weather events, so you can see in this first figure here, failure for climate actions, disasters, human-made environmental disasters dominate the risk since 2020. Also, in terms of the impacts and likelihood here, we see the green stuff, environmental risks dominate the landscape. But also we start to see infectious diseases that starts to come up here. And this, if we plot this based on the impacts and livelihood, so again we see this green risk or environmental risk here. Failure for climate action, extreme weather events are very likely to occur, and if they were to occur, or if they occur, the impacts are quite high. Also, we see the interlinkages between these key risks. I think one thing to note about these figures, they were published in January 2020, before COVID, impacted us greatly. And I think next year, COVID risk or infectious diseases will dominate this landscape of global risk. So now let's move to the science and impacts of climate change. Where are we now? So the IPCC, the Intergovernmental Panel on Climate Change, have published assessment reports periodically. We are now in assessment report 6, before assessment report 3, 4, 5. These are some of the findings, and also there are one of the special report as part of this 6th global assessment, which I'm involved, is on this global warming of 1.5. So why 1.5? The Paris Agreement, we have agreed that we need to limit warming by 2 degrees and pursuing efforts by 1.5. Why 1.5? Because for small islands, low-lying island countries, 2 degrees is too late for them. They want us to limit by 1.5. So what can we do? Or even this 0.5 warming matters for some of the communities. Even many of you living in Southeast Asia, in the small islands as well. So where are we now? So this figure shows that in 2015, when this report, 2018, this report was published, we have reached 1 degree global warming. And if we continue with the current emission rate, we will reach 1.5 by 2040, so 20 years from now. So that's why then we say that if we want to limit warming by 2015, between 2040 in 2045, this emission rate, this warming rate needs to reduce already. So we don't have any long time to do something or to make the emission or meet the achievement of global Paris Agreement. So with this 1 degree global warming, what has happened and how has it impacted our societal and physical system? There are 5 reasons for concerns here. So it means the impacts at different degree. So if you see the second figure here, at between 0 to or 0, like a warming to 1, as we are experiencing now, we are the 2 things that we can see going on worryingly are the warm water corals, the color bleaching, and also effect in the Arctic region. So the melting of the sea ice. But then a lot occurring in low-lying coastal areas, small islands, this coastal flooding, and that's why I think now we have seen all of these impacts, which then gets translated in how we measure disasters. And I think this figure here, one of also the very important figure discussed in the climate science by climate science community on this terminology on climate tipping elements. You can see here, and also gets reflected, this is how then this figure on these impacts and risks on selected natural, managed, and human system gets reflected here. So the pink one here, most immediate threat. So we see disappearing of Arctic summer ice, collapsing of coral reefs. We are seeing also starting to see this integration of West Antarctic ice sheet. So these are some of the threats that are occurring right now. But of course, also this blue one here, gradual changes that we may start to see in the near future, and it may continue to do so. And it affects some of the areas, of course, in the Northern America part here, shifting tundra, melting of permafrost. So these are some of the latest studies on climate change. Then, knowing the latest impacts of disasters and also science and impacts of climate change, what are the international frameworks to deal with this here? So, of course, we all know the Sustainable Development Goals. There are 17 goals, starting from no poverty to goal 17 on partnership for the goal, and where these disasters and climate change are located. So this is how the relationship between Sendai framework and the SDGs. So Sendai framework has 7 goals from goals A, B, C to D, and it's directly related to goal 1, 11 and 13 of the SDGs, and that's why I think countries now are strengthening the capacity in terms of reporting, in terms of statistic, and also a connection of data between different agencies, reporting on the progress for Sendai, so that it also meets the goal of the SDGs. This is also, I think, another figure that is very important in terms of the policy for risk reduction and climate change. The UNFCCC, so the UN agencies implementing climate change program, so climate change mitigation, adaptation, also science, capacity building, and finance. They propose that the 3 global frameworks, the Sustainable Development Goals, the Paris Agreement on Climate Change, and Sendai frameworks all have common goals, and the goal is to reduce vulnerability and enhance resilience. So as part of my job at UNU-IAS is to also ensure that our research, capacity building, and also policy engagement with national governments, regional governments, and other UN entities help to meet these commonalities. So this terminology of coherence, so how these parallel global frameworks support each other, but also alignment. So when we say alignment, how these global frameworks gets translated by regional and national government. And on top of that, you may also heard this terminology of localization. How should local governments, local actors implement this global framework? So So we have this, country-based, statewide approach, a whole government approach of implementations in these global frameworks. So in conclusion, disasters and climate change are interrelated. So I have shown you the statistics that climate change influence the frequency and severity of disasters. The number of disasters, so 90% of disasters are climate related. More than 90% in terms of total number of affected and the costs are climate related. Despite geophysical disaster still kills half of people affected by disasters. So the second conclusion is that human impacts of climate disasters and climate change are increasing. So we have seen from the video, we are entering the Anthropocene, we are experiencing the global acceleration, we are approaching these 9 planetary boundaries, and the most probable, based on science explanation, is that human activities influence this. And that's why, of course, climate mitigation and adaptation are some of the solutions proposed to deal with the impacts of climate change. And the third conclusion I would like to say is that science of climate change has improved vastly, with modeling, backcasting, forecasting, data, collaboration has improved. And also I think this is an opportunity for, all of you, a lot of you coming from developing countries, younger researchers, early career researchers. There are a lot of opportunities for us, including myself, to be involved in these processes. And the last conclusion I would like to say is that we need coherence. So I have explained the common goals by these 3 global frameworks, so the SDGs, the Paris Agreement, and the Sendai framework. So coherence is necessary because we don't have a lot of resources. We have limited resources, but also to ensure efficiency and implementation. From international, regional, national, and even local level. So thank you so much, and back to Professor Takako. So back to Professor Takako.
Okay. Thank you, Rianti, for your presentation, and also showing us the data on the climate change things, and that's definitely one of the biggest concerns and issues at a global level, I think. Okay, so we have a couple of questions for you. This is very fun. I mean, the very general and basic question. And how can we reduce global warming effectively?
Okay. So so global warming, we know that human activities or human effective influence. In this case, we measure it through emission of greenhouse gases. So to reduce or limit global warming is what is basically the Paris Agreement has suggest us to do. So what are the key actions for Paris Agreement? So it's in general it's divided into 3 to 4 actions. So first of all, it's mitigation. Mitigation, it's about first reducing the emission of CO2 to the atmosphere. And in the future, we need to capture. So this terminology of it's BECS, carbon capture and storage. It's about getting some of the CO2 emission that has been in the atmosphere and put that back to the ground. Yeah. So mitigation, clean energy, technology are some also other activities that we can do to limit emission of CO2. But then we have already have the CO2 in the atmosphere, yeah. So we need adaptation, and adaptation are mostly local, are mostly in poorer country, developing countries, small islands, and that's why adaptation is necessary. Then, of course, we have climate finance and climate technology and capacity building. So these are the 5 strategies by which Paris Agreement call and at the UN level. So the UN FCCC based in Bonn coordinate the implementation of the Paris Agreement on climate change. Thank you.
Okay, thank you so much. And another question is that it's a little bit terminology things. Why do we talk about development at speaking on climate change when it's clear that the biggest producer of this phenomena is growth? So why we have abandoned the question of changing our growth model?
Okay. So I think first of all, discussing development is necessary. Risk-based development is important to help us reduce disaster risk. Also, we know that development or growth is the main driver, which then leads to this increased emission of CO2. So what has been advocated now is on circular economy, green growth, by which we need to decouple the use of carbon through intensification, technology, disruptive technology, so that we can still continue to develop. We still need to develop because half of the population are still poor. We still have poor and middle income country or low level of development countries still aspire to have the same lifestyle and the same economic level as what has been achieved in other countries. So development is necessary. However, we need to do development differently, and that's also this terminology of green growth, circular economy, green development is necessary. And also taking into what we are experiencing now with COVID, we are saying that we need to be careful and ensure that COVID recovery is to be first green, to be resilient, low carbon, and also inclusive. And that's also the key things when we do development. So I think coupling climate change, global warming, disaster risk reduction, and development is necessary. Thank you.
Okay, thank you. So since you mentioned COVID-19, so I will ask you about COVID-19 related question. How have COVID-19 impacted the progress of SDGs? The new normal, is it a positive or negative progress?
Okay. The SDG report was I think issued a week ago. So the key decision is that the progress of SDG is halted greatly by SDGs. We know in the short term poverty will increase, and it's the rate that we have even 20 years ago. We have, of course, the discussion of some environmental gain. So we get cleaner sky, we have people less traveling, we have less pollution, but it's only a small part of small and short-term environmental gain. But the long-term societal and economic impacts are dire, and that's why we and a lot of money are being poured into COVID recovery. So as risk reduction, climate adaptation scholars, it's our responsibility to ensure that the money that gets poured into COVID recovery do not just forget what we are discussing about, ensuring that it's green, it's resilience, it's low carbon is necessary. Thank you.
Okay, yeah, great. Okay, thank you, Lianti. And another question is that probably the relation to the DR measures and the environmental protection. So impact of certain DR measures to the environment seems ignored or less emphasized. So protecting human is important, but protecting the environment is important too, of course. So do we have any possible measure to protect both under, human and environment under the increasing threats from the many potential disasters under climate change?
Yes, so thank you so much. Also another great question. Only I think 2 days ago, we celebrate World Mangrove Day. Yeah, and I think mangrove is one of the most, I think, powerful example by which disaster risk reduction and environmental protection needs to be linked. We know after 2004 Indian Ocean tsunami, countries or some part of the countries that are well covered by mangrove, of course, get safe. Were able to reduce number of death and economic damages. IUCN and PEDR also publish the nature-based solutions to climate change and disasters only also 2 days ago. It's about documenting benefits which then can be utilized to of course reduce disaster risk and also advocate for our environment. And I think nature-based solutions. So I have shown you in my presentation these three circles of the SDGs, the Paris Agreement, and Sendai Framework. And in the middle, it's about reducing vulnerability and increasing resilience. Nature-based solution, I think one of the most important solution by which through selecting the solution, it will enable us to achieve this common goal. We will be able to get to improve livelihood of people living around coastal area through this mangrove protection. We will be able to reduce risk because of reduction in the exposure to strong wave, and also on climate adaptation. 1/3 of emission generated a lot in Southeast Asia are due through this destruction of mangrove area. So one of the solutions, some of the countries in Southeast Asia and also South Asia and the Pacific try to advocate is through planting mangrove, because it can help to limit emission through reduction and offsetting of CO2, but also achieve the goal of risk reduction and the SDGs. Thank you.
Yeah, thank you. Yes, definitely the protecting the environment is it's one of the measures, I'm sure. So another question is that, how do we need to keep up with all the updates of the changing science of disaster and climate change in terms of the risk perception for us humans and also other aspects like environment and animals?
I guess if I would frame your question differently, maybe I will take my own, experience on keeping up with science. I'm also 7 years of finishing my PhD in disaster risk reduction. So I guess using technology, and I would really strongly advocate for policy relevant disaster science. We all, especially those who come from highly vulnerable countries to disaster, have the responsibility to contribute to the science here. So the way to keep up with science, and of course we have technology now, I think it's quite easy. Access to with Google, with all this technology, it's quite easy to keep up with the latest development of science. And also, I would strongly encourage the participant, if you're early career researchers doing your master, PhD, postdoc in disaster risk reduction, you also need to contribute. I think professors, more senior researchers rely on this periodical review of what has been the latest science. And I think all of us has that responsibility to ensure that this science gets updated all the time. Yeah.
Okay. All right. Okay. So this will be the last question. So how can we convince the third world developing countries to adopt new eco-development models, such as the use of green energy, knowing that developed countries were able to reach where they are now due to the development models that have greatly impacted climate change?
Yeah, I think this is something that has been discussed in the international sphere. The largest emitters of greenhouse gases is affected the least by climate change, and small islands, countries in Africa, countries in Asia, poorer countries in Asia are the least emitters of CO2, but affected greatly by the impacts of climate change. So how do we encourage this? And this is exactly also what the UNFCCC has been advocated for. This climate finance, this use adoption of technology adoption of capacity building are some of the strategies by which affected countries, a lot in developing countries, get assistance and help and also incentive to adopt this new technology. What's also we need to remember is that Paris Agreement is our, or it's all of us, it's our responsibility, our common responsibility. This differentiation, of course, came out in the early discussion of the Paris Agreement, but I think now it's about implementation, and all of us has this opportunity, responsibility to implement.
Yep. Thank you, Lianti. Yes, indeed. Paris Agreement, it includes the, they emphasize the importance of the help from the developed countries to developing countries. So as you mentioned, it's the time for implementation, and we definitely will like to support that initiative. Yep. Okay, thank you so much, Rianti, for your presentation and answering the questions and all the other questions. And I look forward to our further collaboration in the future.
Yes, and thank you also for the 242 participants who have been involved. Also been great to looking at your profile, and thank you so much for inviting me to this lecture.
Thank you so much. Okay. Okay, so now this is all for today's session and the end of the webinar series of the APRU Multi-Hazard Virtual Summer School. So I'd like to express sincere appreciation to all the speakers today, and also you and the audience, all the audience. And also thank you for sending us many questions, and I apologize we were not able to take all the answers and all the questions due to the time constraints. And also, although this was the virtual summer school this year, I do hope we will be able to host the summer school at Tohoku University again next year. And I look forward to your participation, and I look forward to seeing you face to face. And the regular summer school includes one-day field trip to the affected areas by the Great East Japan earthquake and tsunami, in addition to the 3-day lectures. So you can understand the actual recovery work at the Tohoku region after the 2011 disaster. And in addition to this summer school, the APRU Multi-Hazards Program will also organize the annual research symposium, and it will be hosted by University of Indonesia next year. So the dates excuse me. The dates were not confirmed yet, of course, because of this COVID-19 pandemic. But we will soon announce as soon as possible. The date was confirmed on our website. And furthermore, we plan to organize another webinar series, most likely later September, about a new approach for disaster risk management after the COVID-19 pandemic. This will focus not only for natural disasters, but also biological, chemical, and other types of disasters. And the details of this webinar series in September and October will be also announced at the APRU website. And please be informed that the recording and the slides will be shared by email and on the website, APRU+org. And lastly, but not least, I'd like to thank the APRU Secretariat and the staff who operate this session from Hong Kong for their strong support and cooperation to the Multi-Hazard Program and its event. And I hope to see you once again on another APRU Multi-Hazard Program activities and webinar series, and also the summer school and symposium next year. So once again, thank you so much for your active participation, and hope to see you soon. Hope to see you soon. Thank you.